Welcome to this explainer. I am so glad you're here. As an environmental scientist and field researcher, I spend a ton of time trying to figure out how to communicate the absolute massive, almost unbelievable changes happening to our planet. So today, we're doing exactly that. We're going to mash up two totally different worlds: the rigorous, tried and true wildlife filming rules used by the BBC, and literally the boldest ecological engineering project of our time, resurrecting the Mammoth steppe. If you're a student filmmaker who's super into ecology, or honestly just someone fascinated by nature, consider this your ultimate masterclass. Let's get into it.
It's kind of wild to think about, right? Like, what does composing a camera shot actually have to do with cloning an extinct giant? Well, the mechanics of professional observation basically mirror the mechanics of restoring an ecosystem. Both of them take an incredible amount of patience, a deep understanding of animal behavior, and an eye for the really big narrative, things like carbon sequestration and ancient climate cycles. As we go through this today, you're going to see exactly how looking through the lens of a camera helps us document and, honestly, maybe even save the disappearing secrets of our Arctic ecosystems.
So, let's start with Section 1. The Wildlife Filmmaker's Playbook. 5 Principles for Observing Nature.
Look, we can't just run around the woods with a shaky camera. If we want to really document the impact of animal density on an environment, we need a solid framework. So here are the 5 golden rules of professional wildlife documentary making. 1. Lock off the camera. 2. Frame for where the story is going. 3. Know the difference between your character shot and your action shot. 4. Remember that cutaways are totally load-bearing. And 5. Narrative over spectacle. We're going to use these exact rules today to look at the past, the present, and the potential future of the Siberian Arctic.
Moving to Section 2, framing the Mammoth steppe, locking off the camera on the deep past.
Okay, so our very first principle is locking off the camera. Instead of panning all over the place trying to track moving critters, the pros put the camera on a tripod, figure out where the animal is heading, and just let the movement happen naturally inside the frame. For this explainer, we're going to take our metaphorical camera and lock it firmly into the deep geological past. Think of this as our establishing shot. Back in 1873, the explorer N.M. Przhelski wrote, "If one had not seen this with one's own eyes, it would be impossible to believe that in these desolate areas there could exist such a large number of animals, congregating sometimes in herds of thousands." It's incredible to think about, but during the last glacial maximum, this Mammoth steppe was literally the planet's biggest biome, stretching all the way from France to Canada. Now keep that camera locked off, but let's fast forward the time-lapse to today. The frame completely changes. It's a night and day difference. We go from the Pleistocene Mammoth steppe, which was this incredibly productive grassland holding 10 tons of animal biomass per square kilometer, to the modern Arctic tundra. Today, it's basically mossy forests and wetlands, and there's a staggering 100-fold decrease in plant and animal biomass. Those massive herds of mammoths, rhinos, and bison are just gone. The frame is practically empty now.
Which brings us to Section 3, the permafrost carbon time bomb, framing for where the story is going.
And this perfectly tees up filmmaking rule number 2, frame for where the story is going. If we're pointing our camera at this empty, modern tundra, what action are we actually waiting for? Well, unfortunately, we're waiting for a catastrophe. We are looking at a ticking time bomb, and that time bomb is 1,600 billion metric tons. That's how much carbon is currently locked up in the Arctic permafrost. To put that massive number into perspective for you, that is literally more carbon than what is held in the Earth's entire atmosphere and all its terrestrial forests combined. It's all trapped right now in these frozen soils called eudoma, which are made up of 90% ice. Now, if you want to know what happens when we frame for the future of that permafrost, just picture an ecosystem physically collapsing. When that heavily iced eudoma soil thaws out, it doesn't just get a little wet. It's highly thixotropic, which is a fancy way of saying it turns straight into liquid mud. You get thawing ice wedges, and gentle, sloping hills literally just slide away, transforming into jagged, severe badlands. As a filmmaker, your composition in this moment is capturing a landscape that is fundamentally falling apart. But here's the thing, the camera is only catching the visual collapse. Down below the surface, there's a whole chemical chain reaction going on. As the permafrost melts, these ancient microbes wake up and immediately start feasting on all that old organic matter. And as they digest it, they actually produce their own heat, which speeds up the melting even more. It's a terrifying runaway loop. In dry, aerobic spots, they're releasing carbon dioxide. Underwater, in anaerobic spots like thermokarst lakes, they release methane. To show you how sensitive this is, researchers did an experiment where they just removed the topsoil in one area.
In just 10 years, it caused 4.5 meters of deep permafrost thaw. We are watching a devastating natural carbon cycle break down right in front of our lenses. Let's jump into Section 4, Rewilding to Save Soil, the action shot.
So, how in the world do we stop this runaway melt? That brings us to rule number 3, knowing your action shot. An action shot needs massive physical behavior to push the story forward. Enter the modern herbivores, horses, bison, and muskox that are currently roaming Pleistocene Park in Siberia. For the student documentary makers out there, this is exactly where you'd grab your long lenses. You want to film these massive herbivores from a distance so you don't mess up their natural grazing behavior. These animals are essentially acting as stand-ins today, recreating the lost physical action of the ancient mammoth steppe.
To really highlight that physical impact, you'd want to set up some low-angle, static shots to capture their incredibly heavy footfalls. Why? Well, winter snow acts just like a thick, insulating blanket that actually keeps the ground underneath it relatively warm. But as these big herbivores tramp around looking for food, they smash that snow down. And it is wild. Just 10 centimeters of snow compression drops the deep permafrost temperature by a full degree Celsius. In areas where they're actively grazing, winter soil temperatures drop an unbelievable 15 to 20 degrees Celsius colder. Plus, by eating the dark, heat-absorbing shrubs, they maintain pale grasses that reflect the sun. Their physical action is literally freezing the ground.
All right, Section 5, Engineering the Elephant Mammoth, Introducing the Ultimate Character.
If we want to pull this off on a massive, Arctic-wide scale, we're going to need the ultimate ecosystem engineer. And that takes us to our character shot. It is time to introduce the hero of our story, the de-extinction of the woolly mammoth by Colossal Biosciences. I know it sounds crazy, but this isn't science fiction anymore. It's a very real, active scientific process. Here's how it works. First, researchers find incredibly well-preserved mammoth tissue deep in the Arctic permafrost. Second, they sequence that genome to get a perfectly clear picture of its DNA. And finally, they splice those specific cold-resistant traits right into the genome of its closest living relative, the endangered Asian elephant.
You might be wondering, why go through all that trouble to cast this specific character? Well, because they are the absolute perfect actor for the role. The mammoth has these completely unique physiological traits that make it the ultimate Arctic groundskeeper. They've got super thick insulating fur so they can brush off the freezing cold. They have massive curling tusks that evolved specifically to act like snowplows, scraping and digging through thick ice to find food. And of course, those huge thunderous footballs smash down that insulating snow blanket, exposing the soil directly to the freezing Arctic air. They're basically nature's perfect, custom-built machine for cooling the permafrost. And finally, Section 6, Narrative over Spectacle, Why this story matters.
This brings us to our final filmmaking principle, rule number 5, narrative over spectacle. Look, a beautiful, totally crazy, or cinematic shot means absolutely nothing if it doesn't serve a real purpose in the story. It's super easy to hear about cloning a woolly mammoth and immediately think it's just a flashy spectacle, like a real-life Jurassic Park stunt for clicks. But as researchers and filmmakers, we really have to step back and ask, does bringing the mammoth back actually serve the greater narrative of saving our planet?
The answer to that lies in the concept of a keystone species. That's a species that an entire ecosystem largely depends on to survive. Elephants, and of course their mammoth cousins, are absolutely crucial for keeping their habitats vital and healthy. If you take them out, the whole biome drastically changes. We saw exactly that when the lush mammoth steppe melted away into the super sparse tundra we're left with today. So no, the return of the mammoth isn't just a spectacle. In filmmaking terms, it's a load-bearing cutaway. It is a functionally necessary piece of the puzzle to restore those incredible carbon-locking grasslands up north.
So here we are at the very end of our documentary sequence. We've got our camera locked off, we know exactly where the story is heading, we have our modern herbivores ready for the action shot, and the ultimate mammoth character is literally waiting in the wings. So the question I want to leave you with today is this. Are we going to take action, restore this ecosystem, and lock away those 1,600 billion tons of carbon, or are we just going to pack up our cameras and let the credits roll on the melting permafrost? Think about that the next time you look through a lens. Thank you so much for exploring this with me today, and keep learning.